All right, let's talk about intakes and tunes and why you need a tune if you change your intake. So here's a MAF sensor. This is a hot film MAF sensor. It's a Bosch. I used this Bosch one because they publish their data sheets, which makes it really nice to do this stuff. Alright, so you can see the actual sensor element in here. This is a hot film one, and I chose a Bosch hot film because they're really easy for me to work with. There's no burn off circuit on these, and Bosch publishes their data sheets, which is pretty awesome. So I just googled that number, pulled up the data sheet, and was able to use this guy. So good on you, Bosch. So let's say you were using this type of MAF sensor, right? And then you got a slightly bigger turbo, and it's got the 3-inch, inlet on the volute there, and you thought, boy, it'd be nice to have a piece of 3-inch intake for that, and I'll just cut up this piece of 3-inch. You'd probably use aluminum, not steel, but and I'll weld a little thing on there and stick my MAF sensor in there, and I'll be good to go, right? It's not that much different. Look, I mean, it's only a little bit, right? Well, so it turns out that it's quite a bit. The diameter in here is like 62 millimeters. This diameter is 75. And you just do your pi r squared, you'll get your area. There's a formula to calculate, the change in flow with respect to the area that air has to flow through. So then that's A1 V1, A2 V2. So they are equal. So if you take your area 1 times your velocity 1, it'll be equal to area 2 and velocity 2, assuming a fixed volume of air. So if you assume a fixed rate, which we would be in our case, because say you have a 2-liter engine, you'd keep displacing the same amount whether you had a bigger intake or not. So the math works out that you get a 27% change in velocity. So you can imagine if you took the numbers we're measuring and just subtracted 27% off, that's what your ECM would be saying. So you'd be miscalculating airflow by a considerable amount. So you could really, if your engine control can't account for that big of a mistake, you'd have a bad time. So you'd just be a sad panda. So anyway, when if you do an intake, you change stuff out, you got to make sure to tune for that kind of stuff, because this thing, at least on a mass airflow car, this is primarily what it uses to determine what part of the field table you'll be in. So I hope that helped bring some understanding to what exactly this thing does, how it works, and why it's important. So alright, so we got her plugged in. We got about 12 volts supply, and right now it's reading 200 millivolts roughly on the output of the sensor. We'll just go ahead and plug this guy in here. And there we go. So now we're running about 2.8, 2.9 volts roughly. Alright, so now I've hooked up my, it's like a oscilloscope / logic analyzer kind of multi-tool thing. I like it. That's pretty nice. So what we're going to do is we're going to use that to plot the airflow here. So we're just going to go ahead and hit scan. And we'll plug the shop vac back in. So you can see it flowing there, and it's measuring it out there. We could probably figure out a nicer way to make that line look a little better, but if we unplug it, see it drop off, and that signals what your ECM uses to determine airflow. So if I blow in there, you can see it kind of go up, have little spikes and stuff. So if you change the size of this guy, you'll still be pulling the same amount of air, but this signal will be down, and that will be wrong. So you won't be able to calculate fuel properly on a mass airflow car without, proper calibration for the MAF sensor. So now we're gonna turn this thing on. We'll start scanning, and then I'll turn the shop vac back on, and I'm gonna put my hands in front of the sensor, and in other ways just sort of change the velocity, and you'll be able to see the change in voltage, which represents a change in the airflow or the air mass. Kind of let it stabilize for a second. I'll just put my hand in it just a little bit. So just putting my hands in front of it changes the velocity. And the reason that's a problem is because these mass airflow sensors measure air mass as a function of velocity. So if you change the velocity, you'll change the output, even though the mass flow might be the same. And this would work the other way too if I was in some way lowering the velocity. Like if I pinch this off here, or just changing the output. Alright, so hopefully you have a better idea of how these things work and what they do. If you want to learn more about how they work, there's lots more videos, and then like I said, Bosch publishes data sheets. Their data sheets are actually really good. Tell you all about it. They show the circuit, all kinds of stuff. So check that out if you want to know more. If there's something I maybe missed or need to go into more detail about, let me know in the comments, and I'll maybe make another video or something about it. And then we can go from there. I don't know. I thought it was fun. Maybe I'll make a little flow bench out of this thing.